everybody. Thank you very much for joining me here today. This is Paul Taubman with 9.Connects, and you are in the right place if you are here for our webinar on variants. So to get started here, I just want to start off with a little bit of housekeeping in regards to our questions. We will definitely have time for questions today, so this presentation will not take the full hour, and which is good because I'm going to show you a lot of things, and I'm fairly certain there'll be a lot of questions that you'll want to ask about certain things that you may have seen that I had to gloss over. We will be monitoring these questions, so if you want to, feel free to ask, and maybe we might be able to answer those even before I get to read the list here at the end of the webinar. Also, be specific in the questions. I know I'm notorious about this. A lot of times they'll say we can do this or we can do that, and I'm not being very specific about what I'm pointing to. But if you can also make sure you're specific in your questions, then we don't have to try to get a follow-up in order to provide better information or to actually answer the question that you're asking us to answer. And then, of course, if there's any intricate questions, we can take them offline, and you can get into some very interesting scenarios with variants. So if you do have it, I may say I just don't have the time for this, or I'm not set up to do what you're asking me to do here, and well, you can always experiment with those offline for you. And if, of course, if there's enough questions, I'd be more than happy to put together a Q&A sheet. Those are usually attached to the web page that we create for our webinars. So with that, let me talk about our objectives. There's really only two objectives. The first one is what I'll call expectations. And the expectations are really what variants can do and what variants cannot do. And I think that's one of the biggest problems we all have with variants is that we have some big expectations of them. And when you really start boiling it down, you're going to realize that it's very focused as to what it can and what it cannot do. And we'll talk more about this here in the webinar. We also will take a look at the mechanics of it, in particular what we can do in Altium Designer. So how do we create the variants, and also the what type of outputs do we get from that as well. So we'll look at the bill of materials, we'll look at the out job file, and we'll also look at the Draftspin tool as well. So those are the things we'll be doing here today. So I do want to start off here with a polling question. If you don't mind, don't look here at my screen because I realize I think we added a third or fourth to this one. But if you take a look at the poll and to answer that, I would appreciate it. Okay, so an interesting breakdown. So 42% of you have used this quite a bit, and so it'll be interesting to see if you find anything new or something different that you may have not realized the tool is able to do. Some of you have definitely used it, but you've not done what's called the alternate part, which is what I'm going to spend some time on here today. And then for those 40% who've never heard of it, well, you're going to get the drink from the fire hydrant here. So let's get on with it, and let's take a look at this category of expectations. What I want you to understand is that a variant is all about the component. That's what it's all about. It's not about any other primitive or primitives. It's about the component. So it does not impact it, as I just mentioned here, any other primitive that is. And what can a variant do? Well, when we create a variant, we, by default, leave all of our components fitted, meaning that in our variant, we want to use that component, and Altium by default assumes you want to use the same component that you had for the original design. The second one is to unfit the part, or what they call unfitted, meaning that in my variant, I do not want this part to be populated onto the board. I don't want it in my bill of materials. I don't want it to be in any of my documentation. I don't want to find this part sitting on my board when the final assembly is done. And lastly, and the one that gets a little more trickier, is to provide for an alternate part, meaning that I don't want the original part, I want some other part instead. So those are the three things that a variant can do. So what can variants not do? Well, first and foremost, as I learned the hard way, it cannot manipulate the copper or the wires. And you'll see an example of this as we go along, but this is really important to understand. And not only not manipulate the copper or the wires, it doesn't even manipulate the footprint. And that's what I was talking about here, switch out footprints between variants. And so keep that in mind because we'll see an example again of this in a little bit. The only one piece of advice I'm going to give you here, so I don't forget to mention this at the very end, is this. It is best to consider the variant from the very beginning. As I learned with this particular design, the design that I'm using over here had already been done, and I decided to take it and run with it as the as the example for the variant. So let's take a look at this design. It should look somewhat familiar to you. If you have attended our prior webinar, we use this for our rigid flex example. And by the way, we are actively working on this design. It is what we call the 9-dot die. And it is, as we said, or as I mentioned, used in the rigid flex webinar. So I figured this would be a really good example of a variant. So I created what I call the 6-dot die variant example, where the scenario could be that maybe to bring down the cost or bring down the power, we wanted the traditional 6-sided die. Now, in theory, I could have gotten rid of the middle diode there along with its capacitor, but if you're familiar with the traditional die for a game board or just dice in general, you know that you got to have the middle. You have to have the middle LED in order for you to have a 5 or a 1 in the traditional sense. So we just can only get rid of the top and the bottom center LEDs. And so that's what I'm going to demonstrate here today in Altium Designer. Okay, so enough of the introductory stuff in PowerPoint. Let's get to Altium Designer here. So here is my drawing. And what I want to do is I just want to spend a minute just to give you an idea of what's going on with the circuit, because if you don't really understand what's going on with the circuit, then you're not going to really understand why I'm doing the things I'm doing in the variants. So this is the schematic for this die. And to just give you the 10-second tour of it, we have an accelerometer, and we've got a simple PIC chip, which has just basically one set of buses here, which are broken down to individual bits. So basically, when this thing gets rolled, it's not altimeter, it's an accelerometer. The accelerometer will determine which end is up, and then it will display those the appropriate numbers. So the number is going to be randomly generated from at least the original is going to be 0 through 9, and each of that information is put through each one of these lines here. And what was great about these LEDs that we purchased or found was the fact that we don't have to do any multiplexing or charlieplexing with them. So each one of these lines can go out to each one of the sides of the board, and we have 6 sides because it's a cube. We put them through a bus, and if you're familiar with multi-channel design, what you have to do is this odd little thing where you take the bus and you put it from a bus into a net, and then if you repeat a sheet symbol, which we did over here 6 times, if you want these to come in individually, then this is the configuration you need to do. You have it go from a bus into an individual line because you're not feeding a bus into each sheet. And then you say repeat DIN, and Altium is smart enough to know that this configuration will result in a different bus line going to each one of the sides. So what does the multi-channel look like? Well, here it is. So we've got our DIN line coming in to a gate, and here are our LEDs. So the cool part about these LEDs is that it has an input to an output, and it can be strung along in a daisy chain fashion. So with that, what you can do is you can tell it what color, and you can also determine which one should be turned on and which one should be turned off. And it's all done through basically passing this information through on the single line. Now, obviously, we're using a FET over here to turn this thing on and off, but the control of that is coming from the PIC and processor. So that gives you an overall idea of what's happening here, and there are 9 of these LEDs on each side. So what are we trying to do with our variant? Well, the short of our variant is we want to get rid of D4 and D6. So D4 and D6, and let's bring up our die over here. So a typical side looks like this. So we have our D4 and our D6. We want to basically remove both the capacitor and the LED from D4 and from D6 on each one of these sides. So that is the plan of attack here for our variant. So with that being said, let's take a look at that. Okay, so I don't have a variant yet, so I want to create one. Easy enough to do. We can either go to our PRJ PCB, right click and go to variant, or we can go into project and we can click on variants over here. They're gonna look the exact same. So initially it may look overwhelming, but really what it's doing is it's just giving you a list of all of the components that are in your design. And that's all it's doing here. So to create the variant, all I need to do is to click on add variant down here at the bottom, and it's now gonna prompt me for the variant. So I'm gonna call this one 6 dot. Oops, not caret dot, 6 dot. There is a feature in here for allow for variation of fabrication outputs. And I have to investigate this in a little bit more, but let me give you 2 thoughts on this. First and foremost, this variation of fabrication outputs would be a little unusual because once you see how this works, I'm not really sure you would even have too much variation of your fabrication anyway. So when you really think about it, a variant has to do with components, and components in particular have to do with assembly. So really what we're doing is trying to determine what we're going to assemble and what we're not going to assemble. And secondly, in the out job file, you can control what gets created anyways for each one of the variant. So I'll leave that to you here. And as I said, I probably should spend a little time on this, but I wanted to focus on the bigger picture. Now, for the parameters, I'm more than happy to show you this if somebody wants to see this, but it's going to kind of distract from the now. And again, I'd like to kind of show the core features. And if someone wants to see what happens with the parameters, I'll be more than happy to do during the Q&A. Just make a comment for that, and then I'll come and visit this. But if I go here, then I've got to go into the project options and set up a few things, and I just really don't go down that rabbit's hole for the moment. So I'm going to press OK, and now my variant has been created. Now, what can I do with it? Well, by default, everything here has been fitted. So I have my option of either unfitting something, or I have my option of creating an alternate part. Let's do the easy one first. Let's simply just unfit a part. So remember, I got to get rid of the C4, or the C4 capacitors, which there are on multiple sides, because it assists with the LED, and I don't want the LED, so I don't need the capacitor along with it. You'll notice over here that there is a C4 as the die itself, and then they have each of the sides. And I've done some experimentation with this, and I have found that if I was to just simply declare this one to be unfit or not fitted, so I'll say not fitted over here, this will have no impact on anything. I actually have to go to each one of these individual capacitors on each one of the sides and declare it to be unfitted. Now, fortunately, I can hold down my Shift key, so I'll do that here, and I will right-click on the last column here. I've noticed if you try to right-click somewhere else, it may lose the selection that you have here, but I'm going to right-click. In this case, it did. So let's just one more time, and I'll click down here, right-click, and I grabbed it. So I'll say set selected as, I'm going to say non-fitted, and now these are all non-fitted as such. And let's just do the same thing very quickly for the C6 parts. So I'll grab this first one, and I'll hold down my Shift key, make sure I grab this, only those I need, and I'll right-click down here, set selected as, and I will again do non-fitted. Now these are all non-fitted this time. I'll talk about the alternate fit ones here in just a moment. Let me just demonstrate this non-fitted for now. I'm going to press OK. So, okay, where are they? How come I'm not seeing things over here on C4 and on C6? Well, there's a couple of reasons. So number one, it's because when I created the variant and after I pressed OK, this shows up here now in the projects panel. In the past, this would have been a drop-down that you would have seen up here. So if you're looking at older videos on YouTube, and trust me, I looked at them because I want to see what they were doing, most of those were done in Altium 17 or prior, and so you will not find the drop-down up here. What Altium did is they basically moved it into the projects panel, and it's just a matter of clicking on the variant here. So if I double-click on the 6 dot, we are now looking at the 6 dot variant. But you're saying, hey, I still don't see any X's or any markings to indicate that D4 or D6 or C4 or C6 have been removed. That's because we are now in the editor page. Remember, we're doing multi-channel. So since we're doing multi-channel, we have what's called the logical page, and this is the logical editing page. So down here, you'll see that this is the editor. But if we want to see what the impact is going to be from a component point of view, we got to look at the individual sides. So if we go to side 1 here, you'll now see that the X has been placed there with the DNP, do not populate. Right? And that's going to be true for side 2, side 3, side 4, side 5, and side 6. One of the things I did want to mention here as well is that where the big X and the DNP come from. So let's go back into project variants, and there's a button down here called drawing style. So in the drawing style, they give you the option for using the graphic. Now, it's really kind of an all or nothing type of thing. You don't get a whole lot of picking and choosing as to how this is going to look. And of course, if you wanted to, you could be kind of crafty about this, and you could create special symbols that you could use so that it might look a little bit differently. But that's what the graphic is doing here. So you can use the mesh, or you can use the red cross. And then if you want to, you can also have this text, which is DNP by default, which is do not populate. If you want to use that, of course, you can change the color. If you have a comment here, you can add that comment in here. I left this in when I was just doing some practice runs, But this is what it would look like by default. If you type in something like 6 dot to represent the variant, then it will tag that on to the comment as well if you wish to do so. So that's completely up to you. You'll notice that they also give you the PCB drawing options as well. So keep in mind that when we go into the variant, this is not a schematic thing. It is actually a project level creature. And as a matter of fact, let me press OK and press OK again here. You will notice that with the changes I've made, since I did not change anything in the net list, what ultimately happened here is that the only thing that really got changed is the PRJ PCB. So the variant information is not necessarily stored in the schematic or stored in the PCB doc. It's actually stored in the PRJ PCB. So that's where the variant information is being stored. That's why this one here is showing the red piece of paper to indicate a change, whereas the two schematic documents and the PCB documents are not showing that whatsoever. Now for the PCB doc, just to show you that it was impacted, let's bring that up. Now, we're not really going to see it over here, but if we hit the 3 key, you'll now see that these capacitors for the top center and the bottom center have been removed. And if I want to see the original variation, I can just double click here in the projects panel and it will bring it back. So that's the way we basically go between these variants. And what you're going to find, by the way, and I think Altium needs to kind of standardize on this a little bit more, but in some cases, if you're in some type of tool, in some cases, they'll give you a drop down to say which variant you want in some properties panel or in some dialog. And other times you just got to click on it in the projects panel to switch it out. So you'll see that as we're going along towards the end. So that's what we've got. So we've got the capacitors out of the project. Now let's take a look at what we want to do here. I'm going to hit the 2 key. So what I need to do, because this is in serial fashion, is I can't just simply remove the D4 and the D6 LEDs, because then I'll break the chain here. So I've got to have some type of wire that's going to go around. So in my first methods or attempts at this, I'm going to show you what I tried to create for the alternate part. So I'm going to bring up my schematic library and I'll show you what I created. So I created this thing called the LED bypass. So I want to make sure that we had this line that went through here. This up here is VCC, this is ground. I don't need to have any connection to that. And this was the footprint that I created. So I basically took the same footprint that the LED used, but I decided to do, I short-circuited it within the footprint. So this was going to be my attempt at it. So let's see what happens with it. So I'm going to go back into my project and I'm going to bring back my die. I'm just going to go back to the schematic here. We'll go to project and we're going to go to variants. Okay. So what I'm going to do is I'm going to head over to the D4 and the D6. So here's my D4. I'm going to hold down my shift key so I can grab all of these. And I'm going to right click, set selected as, and I'm going to say alternate. I have no alternate component yet, so it wants me to choose one. So it's going to show me my libraries. So I'm going to click into the NDC SCH lib here, and I'm going to select LED bypass and press OK. And I'll press OK again, and now I've got it. I just have to do the same thing for D6 here, so give me a moment to do so. So we'll grab this one there. I'm going to right click, set selected as alternate, click choose component, and again do the same thing, NDC SCHLAB, and we're going to grab the LED bypass here and press OK, and now we are done. So you can see that these have been put in and there's no errors or anything like that, and we'd be good to go. Well, if we do add an alternate part in here, well, guess what? It does actually impact the net list. So I do actually have to push an update ECO over. So I will bring up the ECO. So let's go here into our design update. And you'll see now that it's trying to add in those jumpers. Now, if you're, I probably should have mentioned this to you, but if you really looked at the original part, the designator was actually JMP question mark. But notice how it actually picks up the designator of the original part. So that with an alternate part, the original part still kind of has some ownership of things, including the designator. So even though these are all showing as a D for diode, really what I've got in here is a jumper. It's also going to try to add in all of these pins as well. So before I hit the execute changes, I want to go to our second polling question over here. So the question I have for you is, what do you think is going to happen once I execute this? So the first scenario, is the alternate foot going to replace the existing footprint, or is the alternate footprint and the existing footprint going to coexist, or is the alternate footprint not going to be introduced? Okay. So you have an interesting spectrum of answers. So let's execute the change and see what happens with this. So I'm going to execute it, and you'll notice that all these are positive. So I'm going to close this, and I will do what's called a VF, which is a view fit, so we can see this. Actually, let's do a view VD, which is a view document. You can see these as well. So it actually introduced the new footprint, but it does not remove the old footprint. So if I was to take these and overlay on top of these, it's not going to work, because what Altium is not going to do is swap footprints. It is going to say, and that's why at the very beginning I want to make it clear that when it came to variants, it's only about whether or not you can populate a component. But when it comes to copper, it doesn't get changed. So this method won't work, because even if I overlaid it here, I'm going to short circuit it every single time. So I have to pick up on a different way of doing this. The other thing I was trying to do too, as a side note, was I was hoping to put just a wire down here, but then I have no control over it, because again, it's not a component. So I had to come up with another method of doing this, and I'll show you that here in just a moment. There's one other thing that I'd like to show you, which is really important to note, and especially in a multi-channel design. So I will press, I'll just do a Control Z here to remove this. But let me go back over here to my design and show you a few things that are really important, especially with multi-channel. So in a multi-channel design, when it comes to fitting or unfitting a part, you can do it to any one of the designs, and Altium is going to be okay with that. So let's say, for instance, for some reason, I want side one to actually have all 9 capacitors onto it, and I want to fit my, well, actually, I won't talk about the alternate part just yet, but for some reason, I want to have all 9 capacitors on side one. So if I go back into my project, go into my variants, and I go here and say, all right, I don't want to fit side one here. So, oh, another little thing, and let me show you what's going to happen here. If I just simply hit my delete key, go down here and hit my delete key again, and I press OK, nothing's going to happen. And in fact, if I go back over to my project variants and I go back into my list here, you'll see it's still non-fitted. So if I want to make this fitted, I actually have to press on the individual button or select multiples and right click and use the selected as and hit the fit and then press OK. So that is how I have to remove it. And then I'll press OK here. And you'll notice that on side one, these have been reinstated, and on side 2, side 3, side 4, side 5, and side 6, they have not been reinstated. If I go back to my PCB Doc and I hit my 3 key, you'll see now that, let's go to number 1, that the capacitors have been reinstated, whereas on all the other sides, they have not been reinstated. So on a multi-channel design, you can definitely do a fit, unfit per channel. What about the alternate part? It won't allow you to do it. Or you can try to do it, but they're going to forewarn you that you can tangle up your net list pretty badly, and I have done that, so their warning is valid. So what happens if, for example, I go back into project variants and I say, okay, I'm going to remove one of the bypasses, and that's all I need to do is just remove one of the bypasses here. So if I go into this and say, you know what, I'm going to switch this back to fitted, I press OK, then you're going to start seeing these tildes all over, or little squiggles on all of your other parts, because what Altium's going to complain about, hopefully you can read this, it's basically popped up an error saying unsupported multi-channel alternate item. So it doesn't like these things, because it's going to really mess up the net list when you do something like this. So just a caution that you have to do something where you're using an alternate part in a multi-channel device. You may not be able to necessarily use multi-channel in the way that we have set it up. There are alternate ways of doing it where you have them on individual schematics, and then if you want to make use of the multi-channel for copy room format purposes, there's ways of setting up the channel, and I think there's some explanations out on the internet to do that. But if you're trying to do it through the classic method, this will not work. You will have some issues with the net list. So I just wanted to bring that to your attention. So with that being said, what do we need to do to use an alternate item to make this work? Well, I'm going to show you another design here, but what I'm going to do is I'm going to close these out so I just don't confuse them. So let's close out these projects. I'm going to save none, press OK. And if there's any questions later on, I'll certainly bring that one back up. So let's bring back our schematic and our PCB. At least we'll start off with those. And in particular on the PCB, this is what I had to do. So, and I did all this because it took me a good hour to introduce the parts and to draw these out and to move a few things around so that I could strategically place this in. I do have an alternate part in here. Okay, and this is again multi-channel device. I've done this on all of them, so I'm not trying to break any of the rules about having something on one multi-channel and not having another one. All 6 multi-channels have the same thing on what you'd call your D4 and your D4, D6, C4, and C6 components, but D4 in particular. What I did was I put a 0 ohm resistor in here. And so I had to put this in here and then I had to string it out. Just simply, again, goes back to the rule that even if I have an alternate part, it's really about which part do you want to populate, this part or its corresponding alternate part. And that's why if you look here, and you'll see this if I hit the 3 key, that if I go to my 6 dot here, double click it here, so this, again, remember this D4 and this little resistor are the alternate parts to each other. So when I go into the 6 dot, this is the alternate part. If I go in the 9 dot, this is the original part and the alternate part goes away. And the capacitor one is really just a matter of whether we fit it or not. So that's how this works. So again, it's about whether we populate the component. It's not about swapping out copper. So that's the point I really want to drive home. So what does the variant look like? Let's take a look at that. So we go here into the variant, and you'll notice now I have my 6 dot variation. Here are my unfitted parts. And then you'll notice here that this was the bypass that I put in. So this is the bypass representation. I'll show you the schematic in a minute for what that looks like. And of course, on the 9 dot side, I'm fitting everything. But also notice here, I didn't have to re-declare my diodes for this. So if it's empty, it knows that the original variation is the same variation here. Now you may have also asked to yourself, and this does work sometimes, how come on the no variation looks a lot like the 9 dot variation? Well, sometimes what I found was that the no variation would show everything. And so it wasn't, so I didn't have confidence in it. So I said, okay, if you're going to show me the 0 ohm resistor sometimes, then I don't know what you're going to provide me for assembly information. So I'd rather specifically have a 6 dot version and then have my 9 dot version. What does the schematic look like? Again, we got to go to the editor. Let's go to side 1. Let's make sure we are on the 6 dot so we can see it. And that was the resistor that I put in here. Okay. So that's kind of the general tour of those things. Of course, if there's questions, feel free to ask them. What I want to show you now is the output. And we'll look at the 2 forms of bill of materials. We'll look at the out job, and now we'll take a look at the Draftspin tool as well so you can see what happens. So since we are in the schematic, let's go up to reports, bill of materials. This is the classic way of putting together a bill of materials. You'll notice very up to here on the top, 6 dot, 9 dot, or no variation. So this is how you can control whether or not you're going to see this. One thing that, again, I find a little unusual is if you look at the 0 ohm resistor, what's its designator? Its designator is the diode. And as a matter of fact, I want to show this to you just because I want to drive home this point that it really is just an alternate part, and Altium's going to keep it as an alternate part. If I go into the 2D mode by hitting the 2 key, and I double click on this part here, notice what the designator is. It's not an R designator. It is a D designator because, again, this is an alternate part. So there's that there. Let's go back into our bill of materials. There's not much more to show than other than the fact if you go to the bill of materials and you switch from one to the other, you'll see that it jumped a little bit. So it's going to remove those things that it does not need, and it's going to add things depending on what you're in. So in the 9 dot version over here, it removed all the 0 ohm resistors. But the other thing it will do too is that the quantities will change. So in the typical 9-dot, we have a quantity of 54 of these diodes. So if I go to the 6 version, you'll see this now drop to 12. And the same thing with those capacitors as well. There was 54 of these capacitors, and if you go to the 6-dot version, there's now 42 of them. So the bill of materials does respond accordingly to what you do in the variant. What about the BOM Dock? Let's take a look at this one. I had a little bit of fun with this because by the time I was done, I could see the cost difference between the two. So in the properties here, you don't have a drop down between the 6-dot version and 9-dot version. This is one of those examples where you actually have to go back to the projects panel and then click on the variation that you want within the project. So let's double click on the 9-dot version. So you can see that on the 9-dot version, again, things change out. Again, they're using, in this case over here, it looks like they actually use the proper R's rather than the D's in this, but you can see that it did modify itself. I'm not sure why it gave it oh, actually we're in the 9-dot version. Let's go to the 6-dot version. Okay, it did do it. It's still doing it properly. There's the 0 ohm right there. But again, notice that the designator is still showing a D and not an R, so it didn't fix that. I was looking at the wrong resistors. But notice the price as well. I thought that was kind of interesting. So when you go into the 9-dot version, it's a $30 bill of materials with the LEDs being really the most expensive element of this. I can pull this over, you can see what those are. And so you can see it's $23 for those LEDs if you're using 6 of them or 9 of them. And if for 6 of them, it goes down to $18. So you can see that's what it costs to do it. That's one of the neat things about the BOM Dock. Let's take a look at the out job file. So the out job file, let's bring that open here. So with the out job file, you have a lot of different options. My personal recommendation is that you create an out job file for each variant. But if you want to keep everything into a single out job file, you can do so. So you have these buttons here on the top. So you can say choose a single variant for the whole out job file, and it's just a drop down, and you can pick it this way. So you don't have to worry about this. You're saying, look, if I'm doing it for 6, if I'm going to do it for the 6-dot, then when I press these buttons, then by golly, it's going to do it for the 6-dot. Or you can create a different variant for each output, and you can break it down further. So, and that's what I was demonstrating here. So when you click on this, it actually adds in a new column that says variant, and when you add something to it, so if I would say add new, and I'm going to do, for example, a Draftspin, let's just say this one over here, it can actually change this over to the variant of 6-dot or 9-dot. And then from there, the output container would drive which set of PDFs I'm creating them for. So if I want my 6-dot ones, I could do this. And if I wanted to, I could add this one in there as well. Same thing for the 9-dot. If I wanted to add in, so this was that. I didn't create another Draftspin one, but I can clone it pretty quick. So let's do that really. So let's duplicate it. We'll call this one 9-dot, and I can add it in. So there's different ways of handling the variants. As I said, I think it's almost better that you just create a separate out job file so you don't accidentally put the wrong things in the wrong out job folders in your project. And the last one that I'll show you over here is the one for the Draftspin tool. So let's bring the Draftspin tool up. So we do have it, and I just got a few little examples, but just to show you the concept here. If you're familiar with it or not familiar with Draftspin, it's kind of a neat tool. You just open it up. If you go in the place menu, you can drop a lot of things down here, and it will instantly draw these things out for you. And that's what makes it very simple and very powerful. But can it do variants? The answer is yes. So if I click here, so notice, for example, that there is nothing here but the 0 ohm resistor. If I go into the properties, so this is not a project thing where you click on your variants in the projects panel. It is when you go to the properties and you scroll down, and buried in the properties, you'll see a variation called 6-dot, or you can change it to no variant, which Altium is treating as the 9-dot, which I don't care for, but at least it gives me what I need over here. So it actually changes this out. And the same thing is true for the other things, even like the bill of materials over here. So when you drop a bill of materials down, if you go into the properties, you go into the variant, click on 6-dot, and do no variation, you'll see that it does modify this. So it added in the additional capacitors, since this is the 9-dot version of it, and it removed the 0 ohm resistors. So there it is. So there is some of that type of activity there. So that is my introduction to variants. And What I'd like to do is I do have one more question for you before we jump into a little talk about 9.connects and some Q&A. So I'd like to bring up the last, our last polling question here. So I'd just like to know what you thought of it, and more importantly, did you get something from it? Great, really appreciate that. So well over 90% of you were pretty happy with it, and I appreciate that. So give me a moment here to talk about 9.connects. In the meantime, feel free to write some questions and I'll take a look at those here. So I'm going to bring my presentation back up. You are here for a reason. So why are you here? Well, this is another value added feature in Altium that you'd like to know more about. So Altium does have a lot of these great value added features. Sometimes we call those spec ops features. They're features that really kind of require you to go a little bit above and beyond the normal flow of Altium Designer, but they add them in there as a value added feature. That's what you're paying for in a tier 1 tool. You probably have also looked at the videos. They are what I consider to be a bit scattered. You find a good little nugget or two in each video, but they're all kind of done from a different angle. And even I found them to be a little bit incomplete or not always answering the questions that I wanted to have answered. And of course, your time is actually precious. So what you just saw here in about 40 to 45 minutes was about 15 hours of all my mistakes and all the undoings that I learned the hard way. And you don't have 15 hours, I get that. So hopefully this 45 minutes here saves you a lot of time, and will also encourage you to use a tool that you may have not used before in Altium. What do we do here at 9.connects? Well, we do training and services, but I'd like to focus in on the training element for just a moment. So we have various trainings, we'll call formal trainings. We have our boot camp, which is an introduction to Altium Designer. We have this one that's called Spec Ops, which goes into what you call the value added features of Altium. We go into deeper things such as multi-channel design, or we go into vias a lot deeper, or we go into things like X signals. So various things that we do here in the Spec Ops. But one of the ones I want to focus in on today is this one called Full Spectrum. And this is becoming more and more popular with a lot of our customers. So why is it that? Well, in one sense, it's pretty much a combination of boot camp and Spec Ops. But more importantly, what we're trying to do is we know that there are people who know how to use Altium, and at the same time, they want to use the value added features of Altium as well. So what we came in is we took the features of boot camp and we took some of the things in Spec Ops. And in the boot camp side of things, we do cover things that we cover in the normal boot camp class, but it's a little more accelerated and the exercises are a little more advanced. So it's just a good refresher for those who, yeah, I remember seeing that before and I've kind of used it before, but it's just a good refresher of seeing those things again. And in terms of the spec ops side of it, what we have found is that instead of just trying to show you, 10 different value added features of Altium, maybe 8 of which you really don't care about, because there's only so much time, yes, we do the boot camp topic, but then you pick 1 or 2 of the spec op topics that you're most interested in. So basically that whole time you're there, you're not wasting any of your time on a topic that's of little value to you. So that's how we work the spec op class here. And that's what you get. You get a good review of Altium Designer, and you also get to dig a little bit deeper into an element of the tool that you wanted to know more about. So if you have more interest in this, do check us out here on our website. So it's 9.connects.com. And if you go to our training on the top button, then you should be able to find what we call the full spectrum and find more information about it. And lastly, thank you very much for joining us here today. And we'll see you at our next webinar.